Hi everybody! So the idea of harnessing the Earth's electrical energy from the Earth's natural properties dates back centuries. Of course, these days we understand an Earth battery in the context of using buried electrodes to generate electricity, but that's something that emerged more recently. The fundamental principles have historic roots. The concept is probably drawing from works like Luigi Galvani and Alessandro Volta of the late 18th century, who did all the pioneering work on batteries. Of course, Volta's invention, the voltaic pile, which was an early form of battery, was really just alternating discs of different metals separated by an electrolyte-soaked cloth. And what it demonstrated was the generation of electricity through the contact of dissimilar metals in a conductive solution. However, the specific idea of using the Earth itself as part of a battery system began to gain attention in the mid-19th century. It was in 1836 when the English physicist Lord Kelvin, William Thomson, proposed using submerged metal plates in the ocean to generate electricity, recognizing the conductivity of seawater and the potential for power generation. Throughout the 19th and 20th centuries, experiments were conducted to explore the electrical properties of the Earth, and various researchers and scientists experimented with buried electrodes and the conductivity of different soils. It was in the late 19th century a German physicist named Friedrich Constantin Reif experimented with buried metal plates to harness the Earth's electricity. It's generally thought that Earth batteries are very little more than chemical batteries. However, it's conclusively shown that Kelvin's seawater battery wasn't a chemical battery at all, and was much more akin to a magnetohydrodynamic generator than anything else. And of course, concepts of being able to tap into the telluric currents of the Earth are one of the big driving factors behind the research into Earth batteries. And even if we were to consider them as chemical batteries, they're much more complex than the chemical batteries were used to, with living organisms playing an integral part in the operation of the battery. But it wasn't until the mid-20th century that the term Earth battery gained more recognition. The interest in alternative and renewable sources during this time led to the renewed exploration of Earth batteries as a potential source of low-power electricity. The batteries have been experimented with and discussed in scientific literature, primarily in the context of educational demonstrations and small low-power applications. While Earth batteries haven't become a mainstream source of power due to their low output and the limitations around them, they are still an area of extreme interest, with people exploring novel ways to generate electricity from natural sources. And the concept continues to be studied, often in conjunction with other alternative energy research, because it's seen as having potential for applications in a huge range of areas.
But batteries are one side of the equation. There's two sides to this. It's not only about energy storage, it's energy generation, and I'm really quite keen on energy generation as well. Now there's an interesting crossover point in Earth batteries. Earth batteries are one of those curious things where nobody's really sure if it's a generator or a battery. Now if it's a chemical reaction and there's a redox reaction going on there, a galvanic reaction, so where you're getting some kind of rusting, then sure, it's a battery. But if you have something that it isn't doing that, where the rusting isn't happening, and there is a huge debate about this, then somehow it's tapping a natural force, in which case it's a generator. Now we don't have to do anything with it apart from stick some metal in the ground or some carbon in the ground and attach it up and use it. So I would say it qualifies as a free energy generator. So there's an enormous amount of debate about this, but to my mind, batteries, Earth batteries, are that point at which storage and generation crosses, and for that I think they're absolutely fascinating. So we're going to have a look at Earth batteries.
Hi, so it's quite a lovely day, so I've come outside because basically I'm sick of being stuck inside. And what I thought I'd look at are Earth batteries. Now, Earth batteries have been known for quite a while, and there's quite a debate about the mechanism of their operation. So for a long time they were talking about whether it was galvanic corrosion of the plates that were stuck in the Earth, and it's likely that that is contributing. But a large reason that they think they work is they tap into something called telluric currents. Now, telluric currents are the natural current that flow through the Earth and the sea, so they flow around the globe, and they're directional, so they flow from pole to pole, and they flow from light to dark, so they flow towards the sun. So the direction that you place things obviously is important and will change. Now, in the northern hemisphere, which is where I am, I'm in the UK obviously, then you get a higher current if you place the anode north of the cathode. I'm assuming that in the southern hemisphere the opposite would be true. Now, nobody really understands how earth batteries work. They were very popular in the late 1800s, early 1900s, because the first investigations and recognition of this as a phenomenon was 1862, I think. I think it was a Swiss guy. Since he discovered that, they got very popular in use for things like running clocks and alarms in houses, that kind of thing. Now, they produce a few milliamps of current, and they're dependent on their surface area. What struck me is that the method of operation is probably very similar to that free energy generator that I did on the members channel. Now, I'm not 100% sure if that's true or not, but it strikes me that there is something linking those things together, and it might be interesting to try and look at what that linkage may be. Now, some of the conditions are that the soil can't be too dry, and that's led people to say, hey, well, it's galvanic. Yeah, maybe, or it might be just that the transmission can take place. Now, the voltages that you get depend on the materials that you put into the soil, and the current seems to depend on the surface area of the material and the orientation of the material. So I've taken a selection of just stuff I had laying around, because all kinds of stuff works, and it's one of the reasons I think that it's going to be good for an investigation during this period, because it's basically just stuff lying around. So I've got a couple of carbon rods that I got from a zinc carbon battery, obviously because of that, a bit of zinc. I've got a bit of brass, I had that lying around from that generator that I made, the free energy one. A bit of aluminium, a steel screw, and a bit of lead that I got from the covering of our house, because we had our roof redone. We had some of this scrap, so if you have a look around, you will be able to find all kinds of materials that you could test this with. So there's an awful lot of things to be looking at. Like I say, orientation, humidity, dampness of the soil, the different materials, what can and can't be used. The anode would be chosen really in relation to the electronegativity of the material, I would suggest. Again, I don't really know. I'm just going on some of the research that I've read around this to make some kind of selection. A lot isn't known about it, so it would be really interesting, I think, to investigate this further and find out what works and what doesn't work. I mean, it would strike me that along the same lines of that free energy generator, if we're putting it into damp soil in the sun, as soon as the telluric currents flow to the sun and evaporation will lead to contact resistance, would it work better in somewhere like England, where we get rain and drying and rain and drying? Would that actually generate a significant amount of power depending on the rainfall? Now, I think that's highly likely. It would be really interesting to investigate. Now, to have a quick look at this, all I've actually got here is a digital multimeter, because that should be enough. I'll be able to get some voltage readings out of it. And what I've also done is I've taken a kilo ohm resistor and just put it there between two clips, because that's going to be a dummy load, so I can get some current readings out of it. And I've equally got my phone here, which has got a compass on it, so I can find out where the north is. So I'm just pulling up the compass. And north is that way. So where I'm sitting right now, that's north. So that's where my anode is going to go. And I'm going to choose a bit of zinc. And distance would be another one. How far apart can we put these? Equally, can we increase the voltage of it if we put several of these and wire them up in series to increase the voltage? Now, I can tell you if they're too close together, no, it doesn't. But what about if they're further apart, or if there's some kind of separator in there? What would that separator have to look like in order to get that to help? The more you put in, you will increase the current, but that's just because you're increasing the surface area. So we put a bit of zinc in there, and then a bit of copper, which actually I'm using brass, Stick the brass in there, we should be able to get a voltage reading out of that. You'll soon know, incidentally, if you've got it the wrong way around, because the voltage reading will be negative and you're looking for a positive reading. Okay, I'm getting 0.72. I'm using brass. Between zinc and copper, it's supposed to be about 0.9. You can actually calculate that. I'm getting 0.72 as a voltage reading. Now if we put our resistor in series with that, we should be able to get an amp reading. I mean, it's going to be microamps, okay? But we should be able to get a reading on that. Sure enough, we're getting a tiny, tiny reading. Now I'll play around with that a little bit and try some of these different materials to see what happens. Okay, so I've put lead in there, and I'm getting 0.21 of a volt when it's against brass. Oh, sorry, 0.21. So obviously lead is an anode material. It's a carbon rod. Okay, that's jumped up to 0.75. That's actually fascinating. So we can try lead against carbon. Obviously, if you're a bit nervous about lead, don't use lead. Copper against carbon gives me 0.6. We'll get the same kind of voltages irrespective of the orientation. This north-south orientation orienting towards the sun, the diurnal orientation, is what affects the current. Oh, that's impressive. Aluminium against carbon gives me a volt, actually, which is kind of cool. Thought I should share with you, I just stuck a bit of magnesium in there because I'd forgotten to do it in the main video, and that jumped up to 2 volts. It's against carbon, so magnesium carbon has an awesome voltage. Try an iron now. It's a lump of steel, actually, and it's giving me half a volt. Actually, it's stainless steel. So you've got a lump of stainless steel and a lump of carbon there. The chances of that voltage being corrosion dependent, obviously, are minute. But it is an absolutely fascinating subject that it is possible to draw this current out of here and make it usable. Now, there were quite a lot of patents, as I say, around the late 1800s, so 1890, 1900, 1910, of various structures you could devise to improve the output of this battery, and you can get useful work out of it. It kind of fell out of favour because the current isn't absolutely massive, obviously, so it kind of fell out of favour, and it's had a huge resurgence at the moment for things like distance lighting of telegraphs, power supplies that are needed to run lights in remote locations, that sort of stuff. The corrosion does happen, but it happens extremely slowly. And when you run these things, or you bury these things in the ground, they have years and years of service life, which is one of the reasons they're becoming more popular now. So if you have a look again on Google Scholar, what you find is there's an awful lot more research papers. Now, I've come outside because it's a lovely day, and I'm just sticking these things in the ground and having a look at that. But there's nothing to stop you making up pots of this, so you get some soil from your garden, put them in some plant pots, and arrange a whole load of these. And that way you'll find that you can in fact connect them in series to get higher and higher voltages, and you can connect those in parallel. I did see an experiment where a chap ran a radio from this. So I thought earth batteries were a really interesting investigation that could be done while you're locked at home and there's not a lot else to do, to try and find some ways of improving those mechanisms, as we suggested: surface area, arrangement, insulation one from the other, dampness, rates of evaporation, orientation to the sun, orientation to the poles, all kinds of things that could be looked at that would be really, really interesting. So I just thought I would share that simple idea with you, and hopefully it's spark off something to do maybe with the kids if it's not something you would be interested in doing yourself, because you should be able to arrange enough of these to do something like light up a LED or run a simple motor, and that's going to be really exciting and really interesting for folks.
What I found was that the people involved fall into camps. And there's a whole camp of people who go, no, that's a load of BS, all it is galvanic action and that rod is rotting. Then there's a whole camp of people who go, no, it's telluric currents and the mysterious power of the earth. Then there's a whole group of people who go, I don't care if it works, I just want to build a big one. Turns out there might be another explanation. What you're looking at is bacteria. You can find these in lots and lots of soils. If you wet the soil and the soil holds together, then it's going to be full of these things, and you can see them glistening in the sun. And what they are exoelectrogens, which is a whole class of bacteria that have recently been discovered. These filaments are able to conduct electricity about as good as a copper wire. The bacteria use them for finding food and finding oxygen and conducting the electricity between them as they form these wires. The research on these things are astonishing, with scientists actually growing them in the lab in small pits to measure how well they actually conduct, and to use them to replace wires with biological wires. Now, they're particularly prevalent in airless soils like estuary mud, that kind of thing, but they can be found absolutely everywhere. And the thing about them is that they conduct the electricity outside of the cell down those little wires. Now, they're not the only class of exoelectrogens. There's a whole class of exoelectrogens that produce electricity and a whole class that eat electricity. And that kind of makes sense, because life is really about the movement of electrons. We take in sugars and we make something called ATP, adenosine triphosphate. That is taken to the muscles, which break it down into ADP, adenosine diphosphate, releasing a phosphate and an electron, and that's our electron transport. That's then taken back and made ATP using electron inside of the cell, and that's how we transport electrons around for life to happen. Exoelectrogens transport the electrons directly outside of themselves. If we look at ATP production a little bit more, what we can see is that the ATP is produced by a cascade of electrons from a high energy to a low energy. Now, we do that with glucose, and at the end of the day we need oxygen as the final acceptor. That's why we need to breathe. Incidentally, that's exactly what cyanide does. Cyanide gets between the oxygen and the electron, and so it stops that process and we die. Some bacteria have done away with an awful lot of that process, and they can literally absorb the electrons directly and use those electrons directly to form ATP. Actually, stunningly easy to collect. If you stick an electrode in the ground and put a small voltage on it, those bacteria will be attracted to that electrode. They'll cluster around the electrode, eating the electrons and growing on the electrode. So you can collect these bacteria all by yourself and they will collect on your Earth battery. And they're actually already being investigated and used for things like fuel cells, batteries, and for even cleaning up water. So some of these organisms wire themselves together, some of these organisms eat electricity, some of these organisms breathe out electrons, or if you like, they breathe out electricity. Now, so far they've been found all over the place. It's not like they're rare, they're just everywhere and we haven't discovered them. It just goes to show, however much you think you know about the world is so complex, there's far more that you don't know about it. So they discovered these things, and these things are separate at the moment. So some organisms breathe out electricity, some organisms eat electricity, some organisms wire themselves together with wires as good as copper cables, and they've been individual finds. And what they're looking for, of course, is an organism that does all three of these things, and they reckon there's a high probability of them finding it if they just keep on looking. And given that they've already found, I can believe that too. Of course it's huge and everybody's interested in it, including NASA. I mean, an organism that eats, breathes, poops electricity, wires itself together and lives off minerals in rocks and soil. Who wouldn't be interested? NASA is thinking about packing it into a spaceship and sending it off to Mars or the Moon, because of course you're looking at a small culture and you will grow your energy production when you get there in environments that have no oxygen. It's absolutely fascinating. But when it comes to Earth batteries, it raises that question: is it galvanic action? Is it telluric currents? Or is it an organism we have only just discovered that naturally does this job?
So we're having a glorious weekend, and like everybody, I'm sick of being stuck inside, so I'm back outside under the tree working on the Earth battery. Now, Earth batteries obviously are a fascinating thing, and there's an awful lot of research and some really good information has been posted in the comments. So if you're not checking out the comments, you really ought to, because there's a lot of people contributing there, some great information, well worth a read through, well worth a follow-up on. Now, one of the big problems with the Earth battery is basically, if you like, the entire Earth is, in inverted commas, the electrolyte. So if you stick a whole load of rods in the ground and you try to connect them up in series to raise the voltage, it's not going to work. Now, Mr. Thessalonian tried this, and he did an entire field with massive rods, and he found exactly the same thing. You can't increase the voltage by connecting in series when using an Earth battery just like that. That seems like a huge problem, and indeed it is a huge problem, because how are you going to get the voltage up? Well, obviously I was reading around on this, and I came across a patent for a chap who'd dug pits. Then he treated the soil in the pits, actually with salt solutions, put them back in the pits, and then made his Earth battery up again. That seemed a little bit like cheating to me, but it did strike a chord, because also, if you think about it, the experiments that I'm directing you to, so if you go to Google Scholar, have a look at some of the experiments. What they do is they dig up the Earth, put it into a plant pot, and then arrange a whole load of plant pots around. And somebody pointed out, well, if you're doing that, aren't you just getting galvanic action, because you've removed it from the Earth, and so you've removed it from the effect of the telluric currents? And that seemed like really sensible stuff to me. So putting together that patent and putting together current research, what I thought, how about if you kind of created the plant pot in the ground sort of idea? So I grabbed a whole load of this. Actually, I have a lot of this. It's just ABS waste pipe. It's what is that? 25mm diameter, something like that. It's just plastic pipe. And I cut off some sections at 10 centimetres, and I cut off 4 of them. And I stuck 4 of them in the ground, and they're here. I'm going to give you a better view of that, incidentally, and of the readings, but I stuck 4 of them in the ground. And then I added my electrodes. Now, I'm using carbon and lead, and if you're following the membership channel, you know why I'm using carbon and lead. So I've got a carbon and lead electrode in each of those 4 pipes, and when I connect them up, it's awesome. It actually connects in series. You can increase the voltage. Now I've got 4 of them, and I'm reading 0.944 volts. It kind of wavers around a little bit, but it's 0.9 and above volts for the 4 connected in series. And if I connect one of them, it drops right down to 0.3. So
we would expect 1.2 volts, and I suspect over time it'll climb to 1.2, but even so, it's 0.9 when there's 4 of them in series and 0.3 when there's only one of them. If I connect up to, I actually get 0.6, which is great. So there's something going on between the two, I'm not quite sure what, but I'm getting an improvement in the voltage when connecting them in series as long as I've driven them into a isolated bit, isolated by basically whacking a piece of pipe in the ground. So what I'm going to do now is give you a close-up of that, and I'm going to pull one out so you can see exactly what it is that I did. Okay, so here's one just connected, and you can see it showing 0.398. If I move that to there, take that and connect it to there and there, there we go, suddenly we get 0.67, and if I just keep on going like that to the end, we'll get that increase in voltage. And there we go, 0.98 of a volt. So if I pull one of those out so you can have a look. It's just a piece of graphite rod. It's only stuck in about that far. Strip of lead. Pull that out. 10 centimetres of pipe that I whacked into the earth. Okay, so I've pulled them out of the ground, and as you can see they're a 10 centimetre piece of ABS, and then I stick a couple of electrodes in there, one carbon, one lead. Like I say, if you want to know why I'm using these, then it's on the membership channel. That'll explain why I chose these electrodes, but you don't have to. You can choose any electrode combination you like. Somebody suggested to me carbon and stainless steel. I have tried that and really not got a particularly good result. I preferred this, but you know, it's everybody's experience. Just because one person is doing one thing doesn't mean it's the right thing. It gives you a starting point for direction more than anything. And there are other things I want to do, which is why I'm choosing these electrode materials. If you're uncomfortable with them, well, work with something else. The general principle still works the same. Irrespective of the electrode material you're looking for optimization. But that's how I made them. I just cut off 10 centimeters of this, scraped a piece of ground free, whacked them in with a mallet, and then stuck my electrodes in there. And when I looked at what Mr. Teslonian did, then, like I say, I think if he'd gone around and put in some pipe, and some serious pipe, maybe 4-inch diameter, driven that in, then put his electrodes in there and done his work, I think he would have been able to connect those up in series. Now obviously when they're laying on the bench here and connected in series, then there's no way that they can connect. So at the bottom here there is a connection. It's clearly not enough when it's in the ground to short everything out. But there is a shorting connection when it's actually in the ground. Maybe they're not deep enough, I don't really know. Maybe it would work if we put something else there. Again, I don't really know. But pulling them out of the ground and connect them in series, we get 1.3 volts. That's not the issue. You can do that really easily. You can connect them up in series when they're like this and get the voltage increase that you're looking for. The issue is getting that when you're putting them in the ground. And it seems that putting them in the ground by isolating them with a little bit of plastic pipe around each electrode before you add it actually has the desired effect. Like I say, that was pulled really from a couple of research papers and a patent particularly that I read that I thought was interesting. Anyway, it's an easy way to improve that voltage, I feel, because you're not doing anything, you're just whacking the pipe in and putting your electrodes in, your very small addition, to improve that earth battery generator. So I thought I would share it with you. I hope it was of interest, and thank you very much for watching.